Okay, hello everyone. Thanks for joining again the Escape School. So this morning the lecture is going to be about the reproducibility of the work you did. So Arturo will present what we mean by reproducibility and how to make sure that the work you did is reproducible, right? So as a reminder, so as usual, you can still ask questions on Slack, also on GatherTown, and we will, aggregate all the interesting questions and ask the question at the end of the lecture to Arturo. So Arturo, you can start.
Okay, Fede, thank you very much, and thank you those that are still after 3 days in the school still here. As was mentioned, the idea of this presentation was to give you an overview of what means to be reproducible and why that matters. So let's
Arturo,
have a...
Sorry to stop you. We still have the black screen in front of your slide.
Okay, let me... Now? Sorry.
Yes.
Yeah.
Sorry, thank you. So yes, the idea is to go through these different concepts. So let me just give you a little introduction of who I am. I am a postdoc here at lab, where the school is organized and it's done basically. And member of mainly of two main teams. One is the ESCAPE team, and other is Atlas, one of the experiments at LAC. I study physics and computer engineer in Venezuela. This is where I am from. And after I got a PhD in fundamental and applied physics in the Università di Napoli in Italy a few years ago already. After that, I continue with my Italian colleagues, let's say, but this time as a postdoc in the University of Udine. Later on, or during that process, also as a system administrator for the Atlas experiment, for the Atlas detector at CERN in Switzerland, and also associated to the ICTP in Italy. So again, if you're curious more of the thing I do, and I love to continue be doing here, is outreach. So this is part of this different exercise of extending educational programs to the people and try to let them know as much as we can of what we learn every day here. So a quick reminder, they say, please don't forget that the power of the pen and the paper. Sometimes this is an advice that I give it to myself many times, let's say, because when we start to do a project, a new thing, especially that we are in front of the computer all the time, we tend to jump directly to start to do things in the computer with our keyboard, and maybe a step back and write things on paper can help you to don't get lost into the details or the makeups or the fonts or how it looks like, but simply go for the concepts. And I just, again, this is a reminder to myself, but also to everybody here that that's quite powerful, and that's myself trying to design in some way, but wanted to talk to you today in these two sessions that we have. So it's quite important to, let's say, to put here in my view, because there is many ways to define this, and this is more a compendium of different experience and the expertise of different jobs that we have here. So in principle, at least for me, reproducibility will refer to this series of principles, techniques, and tools, and especially the practical consideration, let's say, that allows to document, that's very important, to recording, to preserve that analysis pipeline. So again, all the chains from the pure data and the code, the analysis that you are doing, all the tools that you have to integrate in order to do that, and the output and how you save that output also. The idea is always to try to enhance, to try to improve the possibilities, or the probabilities of collaboration across different, not only with you, but other people. We also maybe didn't mention enough, but most of us are part of the bigger collaboration. We work together with other people that, as we are right now, are distributed. So we are in different places around the country or even around the world. So it's quite important to have a process that can be reproducible, not because only in the sense that, okay, I produce a beautiful analysis, a complete analysis, and I put it there with the hope that somebody will come and run it. But also take into account this reproducibility in the everyday, because you are very probably not working alone, especially right now. Most of the time you are in the academia or in the private sector, wherever you are, always working inside a team. So this reproducibility, more than thinking that somebody will run your analysis, at some time in the future, has to be seen also as the constant job that you are doing. So it's important because it should be possible to be replicated by yourself. Let's say that sounds easy at the beginning, but I think that you may remember the words of Rachel, the first presentation, our keynote, that say that the best collaborator you have is yourself 6 months ago, and you don't reply emails, no? So have this, the fact that you have to, from the beginning, from the design. So this is why I was trying to put this on about the pen and paper, will be quite useful for yourself and also for your collaborators in the near future, but also in the long future. No? So also it's very important, remember that the reproducibility, once again, at least in my opinion, involves a using of a standard and well-established protocols. So you want something that will ensure that your code will survive outside your computer. That's quite important. No? And that means also, at least in my perspective, especially when you are learning new tools, that sometimes you find a very nice tool that is quite powerful or is quite user-friendly, but also something very important to take in consideration is the community behind this kind of tool. So you have seen through the different presentations during the school, programming language that are supported by thousands of people, tools like JIT that also is supported by many, many people. So it's this kind of thing that you also have to take in consideration when designing your analysis. When it's you who will have the opportunity and the responsibility to decide what kind of tool, and sometimes you have to maybe decide between a less user-friendly but more supporting and in the long term tool or protocol. So this is what this line is about. So we need to be aware of these standards that will allow you also to move through platforms. So this is what I mean about outside your computer, outside your laptop, when everything works, and after when you send to somebody else, you start to have an issue. So yes, that also means that you increase the possibility that your analysis will survive the passing of the time. So again, it's not 2 months, 3 months, but 1 year, it will survive 5 years. Many of us, it will be very challenging, for example, try to rerun our own undergraduate thesis, our own PhD thesis is quite complicated right now for many different reasons. So it's this kind of thinking of or in the future, especially once again, experiments like those that are part of Scape and or very large collaboration usually tend to last many years. Again, it's experiments that can last 10, 20 years. So it's quite important also, if at some point you find yourself as one of the person who decide or have a voice on what the tool has to be integrated into this kind of situation, to be to keep in mind that about the standards, about the protocol, what is well used in the industry, for example. No? So again, all these to be able to start at the starting point when you want to do this kind of analysis pipeline. So another important observation here that generally there is more than one way to perform an operation, to create an object, a digital object or a product, to deal with an issue, to solve a problem. Obviously, I will show you here some of some examples, some tools, some platform, like extending a little bit more what Rachel already presented. But obviously, you very probably will find other tools, etc. So keep that also in mind. You know that it's always more than one way to do the same things. And I guess this is something that I also advise you, to see it through the school, obviously, and I see already in all the chat that you have done during the different conversation, but also in your professional development. It's quite important to be open-minded, that maybe you have a good solution, but somebody can have a good solution also with a very different approach. So about the lecture, or about what the conversation that we have today, let's say that the main idea is to have a vision of this reproducible analysis, to try to review the components. So once I sit down and I start to see, okay, I will have, or I have some data, I will have, or I have some code that I need to produce. I mean, code that is specific for this application that you're creating, for this analysis that you are creating, but also the different tools that you will import, the different tools that you will obviously profit from the community, so don't reinvent the wheel. No? So how we see these elements and start to separate and start to work one by one. So also review how these elements connect, so how they interact, and what I need to take into the consideration designing an analysis pipeline. You will also, I think that's also very important, because you will always be in the real world. What I mean to say that sometimes, we have on paper ideas about repositories, about computer power, about visualization, etc. But you will step back and you will see that you will have limited resources, yes, in terms of human power, in terms of computer power, in terms of time, etc. And there you will have to do a little bit of also economy in those. So to have a very well-defined pieces will be quite important. And talking about pieces, one of the things I also want to explore with you here is to take a look to this so-called infrastructure as a service, that is this AAS and SaaS, or software as a service, because it's more and more important. Once again, when you are in a real collaboration, or even in the private sector, very probably you are prototyping in your computer or in a desktop, but the real job will happen in an infrastructure that is outside your office. Let's say is some place where it's put there so you can run your code, because the amount of data is very large, or because the computation that has to be done is very heavy, or because the software that you need to use is stored and is installed by somebody else in somebody else's computer. So this is what I refer about infrastructure as a service and software as a service, and how you have to take this in consideration when porting, let's say, or when designing your analysis. So your analysis is running your computer, but also is portable to this infrastructure that will be, or is already in place for you to use. Okay. And again, and tools, I miss another S there, because this lecture was sold, at least in the school, as a practical chat. We introduce different tools, or what can be used to do all these things that we are talking about. So a vision of this reproducible analysis, I will start to, let's say, decompose this. Once again, is a personal vision, but trying to put as much expertise as possible on those. So we have the analysis. Let's say analysis code will be the one that you, for example, have been experimenting and playing and enhancing during this the last days. No, so the notebook that you are writing, the macros, the scripts, the things that are specific for the analysis they are doing. Also, you will have the data. So the data, again, in a decent scale, usually is not in your computer, but they have in a dedicated repository. Okay, and also have a dedicated catalog, not only for the data, but for what describe the data. The computational infrastructure, that once again at the beginning is your own computer, that one that is in front of you right now, but at some point will be somebody else's computer or somebody else's installations. And the external resources, so all this software that you, the other instructors have been showing amazing libraries and tools and techniques that you bring from others and integrate into your job. So again, going one by one, about the analysis code is, at least I can define it as the one, as the code that you write, basically. The one that, or you are the collaboration, once again, because we have to keep in mind that very probably you are already, or you will be inside a team doing this, and the team can be 2-3 people, or can be hundreds of people in some cases. In the case, for example, institutional or even multinational experiment. So it's the set of custom or dedicated software, the macros, and that the analyzers co-develop to interact with the data. Okay. So we also have data repositories and catalogs. So again, in real life, this will refer to a storage of the data and also the metadata associated to those. Okay, you very probably, for example, happens that you are part of a team where the data is already produced, is already stored, and it's your job, it's your responsibility to generate a new analysis pipeline, to create a new approach to deal with a particular algorithms, to optimize that algorithms, because it's, you know, the amount of data is larger and larger, and you need to profit of the new computers, this kind of thing. So the data is already there for you, and also has some metadata. So you need to understand what you will need in order to get the data that you that is needed for your analysis. Sorry. So in some cases, this information, this collection, let's say data itself, so those files that you are reading and the files or the pieces of information that define what the file is, you know, metadata as when it was created, what is inside, the variable that you will find, etc. Sometimes also are separated. Okay, so that's something that you can, for example, start to imagine. So this data is the data that the analysis code reads, basically, and produce meaningful results, generate new information. So you can generate more data, sometimes because you filtered, you make it smaller and refine, also because you augmented the data. So not always the data goes, let's say, smaller and smaller, but sometimes your process will be to augment the data for different purposes, and also hopefully also generate some conclusions, some knowledge that you are learning from doing that. The computational infrastructure, so it refers to the computer power that is used for your code, so in order to explore and analyze the data that we just mentioned. So again, sometimes just start with your computer. You have your laptop, for example, that's your computer power right now, but also will be, once again, in the real world, a remote computational infrastructure that can be used on demand, so something that you connect when you need it, thanks because you are part of an institution or collaboration, or sometimes also because you or the company or the institution where you are pay for that. So we also need to consider during all this conversation that we are not talking only about infrastructure in the university or academic institution, but more and more there is an hybrid models where, as I mentioned before, when you put reality to what you are doing, you will realize that maybe it's more cost effective to use some infrastructure external to all this, some commercial infrastructure, at least for some part of your job. So here is even more important, once again, that what you are doing is able to run in different environments. So outside your university, for example. And the external resources, again, the software and others I put here, essentially I will try to encapsulate all that software that your code import. For example, you are using all these different libraries that were mentioned the last 2 days. And that's, for example, something that obviously when you run your analysis in your computer, you have it, but also if it happens that you need to send that code, migrate that code to another place, you will still obviously need to have those libraries, those tools that you have to import. So It's important to also have that in consideration when you are designing. And also do the corresponding version here, no? Like the JIT, that was a very, very, very nice presentations also, and about how absolutely important and is to use JIT and on the different platform, but the JIT is kind of one of these standards that I was just mentioned before, no? That's something that just you have to use and learn in the best way possible to profit of all this technology that you know, and many others also know, so it will be easier to collaborate. So also refers to the platforms that developed, like for example, the Jupyter notebooks. Jupyter itself, this tool, this user interface that you are already using also, and we would use a little bit today, is a common tool. So again, you, the hundreds that participate are in this school, know what is Jupyter, many other people, so it's started to be a kind of standard also. It's not the only one. We also saw during the previous classes, and we will see that there is more than one way to do these kind of jobs. But for example, Jupyter is one of these tools that if you have a Jupyter notebook running in your computer and you need to run it, for example, in another computer, you will also need that infrastructure, let's say that Jupyter, when you, the online editors, these kind of things. So yes, you put all these pieces together, and usually these things are connected in networks, and the usual interconnection between these elements, data, computer power, computers, external resources, and finally your analysis, your code, basically. So looking for those elements, we start to see, at least I imagine this way, you will have three different main pieces. Let's say one is the data sets, or the data, the metadata, the repository, the data lakes, and other forms of storage of data that you will analyze, coming from an experiment, coming from a particular company, etc. You will have this computer infrastructure. That means also the operating system, the file system, the CPUs, GPUs, the chips that you will have, the memory to perform this data analysis, and the analysis codes. So what you are writing, the dependency that you need. So all these libraries, all these particular tools that you are bringing for other communities, and all the related software as a service that is, for example, once again, imagine that you are running a Jupyter notebook in a Jupyter Hub, and we will mention a little bit more about that in the later slide. Is part of that, and let's say the dashed lines here is like, if you in the first approximation you have all these right now in front of you, that means that is your computer. You have a piece of data, maybe a table or a file that you are analyzing. It's there in your computer. The computer power is the chips inside the computer, your RAM, etc. What you have there, and also the code. So these three pieces are living in the single device that is the machine that is in front of you. Okay, but we can also put it separate. So what happens when we do this? So again, we will have the data in one place. We can have the computer infrastructure in another place, and we can have the analysis code, the dependencies in another place. So in this case, again, it's starting to imagine when in real life we will have distributed environment, distributed data sets, or data that is coming, because sometimes it's not data that is only a store. For example, we have seen, or we're talking about data that was already taken, or maybe it's a simulation, maybe it was generated for another code, in part of a previous pipeline. So you have it there. But also, it happens in many examples right now when you have a constant creation, so a fluid, let's say, of data coming because you have analyzing some sensors that are taking continuous data. So you need to pass that data through the process let's say in real time, or almost real time, or you are reading some trends or something happening, for example, in social media. So it's something that is coming constantly. So this data is not with you first because it's produced almost in real time, but it's also coming from a different place. So yes, we talked already about the computer. But again, if we separate it, so we will have computers somewhere else where we need to connect to a network and work with those. And finally, again, analysis code that is not only ours, but also the dependencies, editors, and other things around that make possible to do the development, basically. So yes, in some very simplified version, again, of this, it could happen that where the example I mentioned, the exercise I ask you to do with me is that you will have this movement of data through where the computer power is, yeah? Because it's coming, one, because it's produced in real time, so you are getting this data, or you are reading the data from a different place. One, and here there is, well, there is more than one, but I can imagine two basic modes to do it. One is that you have the data in one place, essentially, and you move it, you stack it in the computer infrastructure, and when it's there, you have your block of data here, and you start your analysis, your process, your application that is happening there. Obviously, in order to do that, also such applications, such software, and I simplify, as you saw here, with respect to the previous slide, I just remove a bunch of these letters, these words, just leaving data, computer infrastructure, analysis code, but keep in mind that these complex things that we mentioned before. So the analysis code, let's say, has to also go where is the computer power. And here, you know, all this smashing and computation that is happening, and all the looking for some clues or some news and knowledge there. No? The other thing that I mentioned that, for example, I imagine two ways that this is moving. One is that you move the data, put it there, you have your code, you run, for example. The other is that you can, the other way I can imagine that this is happening is that you are streaming the data. So in a similar way, for example, that happened when you are watching a video in one of the stream service, no, for a movie or even also a song for music that is coming to you as soon as you are consuming it. No, it's not like the service bring the entire movie or bring the entire chapter of a series or the entire album or music that you are listening, but it's coming to you as soon as you are using it. In this case, for example, if you are watching something in your phone, it's your phone that is doing the computation, but it's getting the data streaming. No? So it's coming constantly and analyzing at the same time. So yes, sometimes the data and the computer are together. So that's another thing that you will find, that coming back to this idea of infrastructure as a service. So again, when you have an infrastructure that is external to your computer, external to your office, where you will have very probably computer power. So I mean, a lot of computer to do this big data, for example, or do this simulation where you will need some data, and they are in principle together. So together means like a very close in the sense that you have a bunch of disks in the same data center, where is the computer. So essentially the distance there can be is very small, so the data is coming to the computer infrastructure much quicker in a dedicated network, for example. So you can imagine that more or less as a single entity, because they are physically, for example, together. But still, your analysis is outside this distributed facility, and you need to ship that code or that analysis and all the environment also to the computer and to do the processing. But as we saw already, this is not done like in the previous slide here. I mean, it's not like we just copy and paste a folder with our code. This is done through most probably versioning systems, and also with continuous integration. This is the CI there, and continue deployment. That is the CD there, and you will see much more in the afternoon of sessions today. But so please, obviously, be in that conversation also. But what is very important here is that, as you can see, you will start to have more pieces. So what we are seeing is, again, that it's not just as a folder, but that essentially you develop your code, because again, it's not only yours, and most probably what you are developing is a tool that is done inside a collaboration, inside a team. So it's happened to have all these things that you already start to see: the fork, the part that you clone your version of the repository, you get it to you create a branch, you do the part of the job that you have to do, solve an issue, put a new feature, etc., and you send back, let's say, this improvement, this new code into the version system. Be sure that it's not colliding with another, that you don't have any collision, any other person was editing the same file at the same time as you. Solve the conflicts, and once this is done, so part of your code is coming inside let's say the main branch of the production one, after a series of tests to be sure that you are not breaking, once again, not only yours, but the code of many other people that is working with you. So that will be the way that most probably you will work constantly. Most of the things, and again, you will see more today, but also happen here that there is a few tests that are run on the system, on the code, to be sure that this the new changes didn't break or didn't bring something that is not intended into the code, because sometimes happen that it's not like it's not compiling or it's not run. It runs and do compile well, but can happen that it's doing a bad calculation. So the calculation happens. That means that the code, for the point of view of the computer, it simply runs. So it's nothing wrong in the process, but maybe the calculation that you are doing is not correct, and obviously the result is wrong. So part of this bubble here will be to have a series of tests that you can implement to say, okay, the code, if I always give it number 1, it will always should return number 3. And this kind of test that you ensure at least that it didn't lose properties or is not giving an intended result, or very, very well known inputs. And that's happening here. And again, when we are doing this kind of analysis by ourselves, we also do this by let's say by hand, in the sense that we maybe are logged in into this computer infrastructure and we bring that code, cloning it there or download it into the place or copying it, depending on the different access that you have. But when you start to again, being in a collaboration in general, that step will be also done by the computers. So after you have these different tests, after all these checks are passed correctly, is the continuous deployment that will bring that piece into the computer. So at the end, you will start to see there is a lot of automation here that it's very important that you continue seeing during the school, because it will save, first, we will save a lot of time. So again, there are repetitive actions, and I am completely sure that you are very aware of this, that you try to find what is the thing that you do every day in exactly the same way. And if it's something that you do every day, very probably there is a way to automatize. So you remove that task from your day by day, and you use that time for something more creative. So again, some very important thing that you need to take into account when doing all this design is to see where are the different tasks that are exactly the same. or maybe not exactly the same, but you can start to step back and say, this is happening every time, or I need to come every day and do this thing by hand. Maybe there is a way where I can ensure that this happening independent, and I don't need to do it myself. First, because we'll save time. That's quite valuable. Also, because make the system more deterministic. So again, it's something that you can also port, because again, if it's not you who will do it, no, but if it's the computer who is doing it, you can port it to another computer and that's the job to the computer. But also, again, in terms of this reproducibility, that is the word that we also should keep in mind all the time during this conversation, is that as if that one, the reproducibility, will become very much together with as many as these tools are, as these tasks are automatized by the team, by you, because that will mean that you remove the human for most of the pieces that maybe are repetitive, and also you remove the possibility to make mistakes. Even when you do the same thing thousands of times, maybe the 1001, you make a mistake. And again, when it's a system that is not only your analysis, it's not only your computer, but it's something that more people is using, is something to take in consideration, that you want to avoid to break something that is ongoing for you or your collaboration, or for example, again, in your job in the private sector. Quite useful to keep that in mind. So at the end, what happened with this is that your computer, so your laptop, the desktop that you have in front of you, is a door to access to these elements. So we will see, for example, right now you have been analyzing, you have been running notebooks in your computer. You set up the environment that was in our repository of the school. So you have some Jupyter notebook. You can create this very nice graph that I've been showing since just the first day with the notebooks. But now you also start to have this vision where your analysis, or your computer is essentially just a window, or the definition of what this many years ago is a terminal. So a terminal was exactly that, a way to interact with a machine that was somewhere else. So in fact, what the computer will be is the end, but your analysis code is developed in another infrastructure. That means outside your computer. So that means the software as a service. So you will maybe be using a lot a Jupyter Hub. So it's a place that is providing for you the infrastructure to run Jupyter notebooks, not in your computer, but somewhere else, because that infrastructure also allows you to have more computer power or very specific chips. You are analyzing things that need GPUs instead of CPUs, and so this kind of thing will happen more and more frequently. So again, you need to be aware of that, and also be sure that your code is running here and there. Also, from the point of view of the data, you can, you very probably are doing it now in your studies, or even your career right now. The data is stored somewhere, and your computer is only a window to explore that in a web application, for example. And finally, the computer infrastructure, that is virtual machines and Docker container that we will see later, that those are the one that produce this, allows you to produce this analysis. So again, you have these different bubbles. They are at least important in my story, because the idea is that you can imagine this as one entity, the versioning system as another server, and you are already doing this because, for example, you have been doing you clone our GitHub repository. So this is living in GitHub servers. Yes, it's a different infrastructure that you are using as a service. Somebody put those servers there and running and making sure that they work every day, but it's not your computer. Of course, you have a copy in your Git and you can develop in the computer, but right now you are using software as a service in this case. So again, seeing in this way, you can have very different infrastructure. So where you put the data, because it's distributed, because it's coming from a sensor, because it's stored in a telescope in some island, and after has to be put it into the computer infrastructure, be migrated there. You have your analysis code that again is not even developed in your computer, but your computer is just only the windows through access to those editor or to those systems. You have the different JITs and versioning system, but also the continuous integration, continuous deployment is another server outside your computer. And finally, the computer power that is also outside. So once again, you need to be sure that what you are doing will be running in these different environments. So some elements, an example here. The other thing that will happen, sometimes is common, especially for scientists, is that the data is also distributed in more than one place. So you will have infrastructure, or you will have experiments or experience where data is stored in more than one computer facility, for example, more than one computer center, because it's too big, because again, it's a collaboration, so they have more than one replica. It's important also to imagine that if you have an experiment that it has to be run for many years, and they are usually very expensive, etc. As we are doing, for sure, I am sure that all of you have a backup of all what is in your computer outside your computer. In a similar fashion, we should imagine, and again, if you are yourself, and you will be yourself in the position to design, to be part of the people who will design this kind of infrastructure, you need to be sure that obviously you will have more than one copy of your valuable data, especially again, when you have an experiment that is quite expensive to run, or maybe an experience that is unique. So that's one of the reasons to have more than one places to have the data. Also happens, again, as an example that I mentioned before, that you have different source of data. So it's even when in this particular, let's say in my bubbles here, it looks like exactly the same. You can imagine that they are different data that you need to put together. So again, see, if you are, for example, analyzing some kind of some social network information, so maybe you have more than one source for those strings that are coming from those pictures that you are seeing, and you needed to put it together. So again, also in this case, you will have different sources, not because the data is the same but distributed, but because it's different. So it's coming from different sources. And again, you bring this data very probably to the computers. You have your analysis code, and through the JIT system to do the proper versioning and to be sure that your code is okay, and do the computation here. But also, you will have the situation where the computer is also distributed. So that means, that you have the possibility, or also the necessity sometimes, of have more than one place. So that happens that some of the jobs that you are running are essentially too big, for example, no? Or the computers need to be distributed because for example, you are doing something that is very low consuming, so you have a bunch of very small CPUs, very small computers that are running, but are in principle in different places. So here, we will start to see also a lot of these environments. Again, if you are new on all this, but very probably also you already are dealing with this kind of situation. What I mean is that the computer facility is not only one, but you have once again, the possibility or the necessity to use more than one. So in this case, the computer power can be distributed or also flexible. So it scales with your necessities. And this is something that happens more and more frequently. For example, there are experience that produce a constant amount of data, you know, and that if you have already, you know what amount of data you have, you can have a defined already computational power already. But there are examples in the real world where the data is coming in, like in bunches. So sometimes you have peaks of data, and at some point nothing, and come back to be a peak and nothing. So in this case, it happened that sometimes if you have a fixed infrastructure, this infrastructure maybe is used to the maximum because you need to consider the computer that you will have to deal with the maximum possible, and and something more. No, you don't live just in the top, but you need to put some more to have some flexibility there. So once you have an idea what will be your maximum, but it's happened that in some experience that is not a constant. Like, for example, one of the things I have been seeing during this looking for different ideas is the booking system, the public transportation system, for example. No, there are particular times during the day, early in the morning, with 7 a.m., 6 a.m., 8 a.m., when the people is leaving their home to go to work, to go to school, etc., where the consultation, for example, of the timetables of the different public transportation, mobile phones or the computer, the acquisition of the tickets for that particular trip that you are doing is happen to be large peaks during a certain moment of the day, but after is very low. So if you imagine that the people who manage this infrastructure will have let's say one option could be to simply have a lot of computers to deal with that peak, but most of the time your computer will be essentially wasted because it's just sleeping there. It's either, better say, waiting for the next one, and most of the day is essentially using a fraction of that computer power, or to have the flexibility that your analysis or your application, that is in this case is analyzing all these requests, will scale with the demand. So in this case, you will have the opportunity to create more virtual machines, and we'll talk a little bit more about that scale with when it's happening something like this, and when the activity decreases. So essentially, you clean those extra computers and you remain low. And that is one of the philosophies right now, and it's also called hybrid cloud, where you will have to mix not only the infrastructure that you have, and maybe rented some infrastructure only for the time where you will need it. So in that case, you will also have to deal with the fact that your code need to scale, need to go through, for example, and again, I will mention a little bit more, this Docker container to be able to grow or to decrease if it's not necessary. And also you can imagine scenarios like this in science, again, when you have some experiments that, for example, in my case, when working at the Atlas experiment, another experience is that when the experiment is not taking data, yes, so there is a bunch of computer on, let's say, on not literally on top of the detector, but let's say on the surface, very close to the detector, that receive that data, do a very fast reprocessing of the data, and is sent it to another place. But this happens when LAC is running. So when LAC is giving data to the detector. But what happens when those detectors are off? Because again, there is no beam, there's nothing colliding there. Those computers are used for do something different. They just not stay there sleeping, but they are used, for example, to run some simulation. Many of the physics that maybe many of you are doing needs not only real data from the experiment, but also a lot of simulation to compare models to verify that something is matching the data, or if you can discard an idea. So that also happens in real life when you have computers that have this flexibility to essentially get some code and dump data when it's necessary, and to remove and put a different environment because it's doing something different. So we always keep the machine busy optimizing the amount of resources, because at the end of the day, again, this is real life. There is money involved. There is resources that need to be used in the best possible way. So doing that, I have this simplified, let's say, selection of pieces. One is, again, the data analysis code, and we mentioned again also the service as a service that you are using, then the Git and continuous integration development, deployment, sorry, and the computer, all the kind of infrastructure as a service. So obviously you can identify more pieces and increase the granularity of this model, but let's at least for the presentation keep this one now, and your computer here, no, in one stream, your door, to all of this. So in terms of software infrastructure as a service, so there have been I have a series of also just pictures to try to simplify some of these scenarios again. So these, for example, have been different pictures or a previous job that we're also doing on try to identify the different environments of these different situations and how we can develop code or develop recipes that will work in as many environments as possible. So something that will be common here, and maybe it's happening right now, is that you will have your computer, when you have the visual of what is happening. You have your terminal writing some code there, executing some commands, etc. But you may be using some remote service to do the computer power. So again, as I was mentioned, you can have my binder, and I will show you a little bit about what this is. Maybe many of you already know, but obviously the idea is that all of you have an idea of what it is. Rachel, I think, mentions you also in the presentation. But can be also commercial cloud. So again, about this renting of machines that you may, or your institution is doing to optimize their resources. And you need to also learn how to deal with this kind of infrastructure that is completely outside of your institution. And again, as I mentioned before, you have some, well, I put here open data, but can also be closed data, closed in the sense that it's an embargo of the experiment, so it's only accessible for the people that is part of the experience. But at some point, this is living in one place. So, and also can be the software. So the experiments tend to also produce big blocks of code that is the one that you also call inside your particular analysis. So this is also distributed on demand, for example, through some file system. So you have a model, more or less something like this. You are writing your code because you are visualizing in a notebook or some kind of web application. So this back and forward, your code is essentially reading some data. So pulling that from, again, because downloaded there, or you do some kind of streaming of the data. So this is happening constantly, and you have this kind of infrastructure here. Let's say your working environment, but you are aware of these pieces. So, but when we have more than one, let's say you have more than one, you also have something like this, for example, where you have these institutional resources in-house or commercial, as I mentioned before. You have Jupyter, CPUs, and temporary hard disk, obviously, to save all this, for example. The data that most probably has to be moved in some way there to be computed. Sorry. And you have, more than one. Right? You have different people working on this. So, so yes, this don't need to be together, obviously, as we are doing right now. Can be distributed around the world, but more or less they are using the same resources. So that's also very important when we are thinking about protocols, when we are talking about tools. This collaboration, or even if you are only more than one, only two people working together, it's very important to find common ground, and that also will have to deal with the different resources. So you need to be aware what kind of computer the other person has, no? And how you can compromise between the two. Sometimes the environments are quite heterogeneous. And because part of all this effort that we are doing today is to make all this science accessible for as many people as possible, all this technique, it's very important to know that not everybody has, a very powerful computer. Maybe some other infrastructure are more modest, and we need to take in consideration that when choosing, again, tools to collaborate. So when I was mentioned before, for example, you may find a very nice tool, a very fancy tool because you have a lot of features that you can drag and drop and put there. But very probably this kind of application is very consuming for other people that wants to be or are part of the collaboration. So you need to, let's say, level down and maybe sacrifice a little bit of the user interface so that more things that can be done with the more modern infrastructure. So this is also something to take into account. So going into this different model, let's say you can have something like that, and it's very frequent where you have an institutional infrastructure. So that means you are working in a university or in a company where everybody, let's say, is in the same network, let's put it like this, and working their computers. And the resources are inside also that infrastructure. So again, it's part of the institution, it's part of this collaboration, but you can put it all then more or less into a single space here. And what is external is the data, once again, because it's data that you don't produce, but it's coming from open source access, or because it's some data that is reading some sensor and given to you, because you are analyzing some social network or something coming from the outside world, no? Completely external to your developing. But again, more and more is happening that some of these institutions tend to evaluate what is the cost and the benefits to have a complete infrastructure that is managed by them. And again, because maybe the analysis have this kind of peaks and etc., that maybe it's more cost effective also in the industry to have still, your workers or your teams working together in a single place. So this, again, a single place doesn't need to be, a single building, but in like a single infrastructure, but your computing power is rented. So it's external because it's rented or because it's borrowed. That can be also be the case. Sometimes you will have, for example, the opportunity to use some high performance computing. So you are working in a particular experiment or analysis, and you may be adding the queue to use a supercomputer. So that supercomputer will be an external resource, something that maybe you don't need to pay for that, but you need to make the queue and apply for that computer power that maybe will boost your analysis, instead of taking 3 weeks, can be 3 hours, because this is a very powerful computer, but it will be a kind of one shot, So if whatever you do, the code, write or run, your virtual machine, your containers are fine. The system administrator will essentially include your code, and let's say they will not review inside, you make sure of some security, etc. But if you produce your code in such a way that was not well prepared and your results are meaningless, you are back to the queue, for example. So that's also very important to be sure that all the pieces are working, because you may have a unique opportunity, a very rare opportunity to use machines that it can boost a lot what you are doing. So being sure that it's working in those environments is quite important. One, because it can be that you are paying for that, or two, because it's one of these scenarios when you are allowed to use some high performance computer infrastructure that, again, is not part of your experiment, but it's something that you can apply for and get some chance, a couple of hours, 12 hours, 6 hours for doing this. And another model that is happening a lot also is more or less in the opposite way, is when institutions allows external users to use the computer power. So again, there have been some services like MyBinder and but also some companies. You have Google that allows you to use many services without paying, for example. At a certain point, you start, if your usage start to increase, you may need to start to pay for that. But it's not only Google. You will see, I have an example with IBM or Microsoft, etc. This kind of, when they have the inverse weight. So if it's an academic institution or some kind of public institution that allows you to use the resources under certain, constraints and premise, and also private companies that allows you to use the resources after a certain point, and after you are, for free, sorry, and after you will need to pay if you need more. But that also brings an opportunity for you to test things, to take these free trials that let's say they give it to you to test what you are doing, to maybe how to say, explore this possibility of cloud computing in what you are doing, and see if it's feasible, if it's cost effective for what you are doing. But also happens, and this is let's say less relevant, but still, at least for me, important, is happening that there is more and more outreach programs that happen like this, that when, again, you have institutions that for a certain period of time allows to use on resources, so you can do something similar we are doing right now, like addition to all these techniques. So here is the second part. So this is why I put the first slide again, so I am sure I am dividing this properly. I don't know if we can continue, or maybe have some question now and come back for the second half.
Okay. Maybe so just this slide, this is for the second half of your presentation in 1 hour, right?
Yeah, I put it here to don't forget myself where I'm supposed to do.
Okay. So what I propose, we can maybe go through some of the question, right? So on the Slack channel, there was a question about reproducibility when data are produced from a proprietary tool, and more especially, like they wanted to migrate and to use an open source tool instead of the proprietary tool like GammaPy or C tool. So the question maybe is, how do we handle like proprietary tool instead of open source tool?
Yes, again, that will depend a lot of what. I will not say let's be against from the very beginning from proprietary tools. It's not the case, and many of these things are extremely well done because they are done for a very specific application. So maybe the best solution there to solve your problems is something proprietary. So I think the answer I will give is that will depend. So first of, if you need to integrate people that have no access to such tool, for example, this is one of the reasons why, for example, one of the main reasons why all these experiments use open source protocol. Again, we are talking about JIT, operating systems based on Linux, and all these programming languages that are open source, is because you want to integrate people. Yes, and again, not everybody has the resources to do it. Also, because you may want to do something with that, improve it or change it in some way. And obviously, if you have something that is private, that will be not possible, very probably. So I think that to try to reply your question, if what you are trying is to integrate more people, or maybe save some money, because again, talking about real life, once again, you maybe are spending some money that maybe you can put in more infrastructure, in a little bit more or RAM in a particular cluster instead of a license. It will be quite important to see what is, the format, the data they are using, and try to find a way to use an open source tool to produce that data and to be able to read it.
Okay. Thanks, Arturo. And there is also another question. So you mentioned about metadata for indexing data.
Mm-hmm.
Like, do you have any advice about any standard Yeah.
So to be honest, I am not an expert all in metadata, but what I can say is that most of the platform, for example, we will, and Rachel showed Zenodo, and I will show you Zenodo a little bit in deep, and we will go for a couple of examples. And those kind of platforms have very good definition of this metadata. You know, again, the simple things from name, authors, what is inside, kind of variables. When it was produced, but it will depend a lot of also your experiment. I think this is a very naive opinion, but also can be relevant, is to put information that you know that will be easier for you to find it later on. So maybe you have some data that is very, you know, beautiful or very specific there, but it's something that you maybe are never using. You are so maybe keywords about what you are doing can be maybe more important, because the idea is that your data is searchable, you are able to find the bug, and others will be able also to do it. And this is why, for example, Zenodo is trying to do another platform. But yes, it will depend a lot on what you are doing. You know, some people are saving also data, but also files or software. So yes, it's very, very different. But sorry that I don't have a particular example for this.
Okay, but I think it's safe also to say maybe that instead of reinventing the wheel, like people, they should look deeply and see if there is not already a standard for a given
Yes,
for indexing
yes.
data.
No, absolutely. This is why, I mean, this effort, for example, that the people put, you know, to design Zenodo, but not only, you just profit that. They have been a lot of people involved behind the scenes to make sure that the metadata that they are putting to you in a form that you need only to fill is not just random, but have been studied. So take it as a model, as Frederick said.
Okay, thanks, Arturo. I don't have more question from the chat. Like what I propose, we can stop here and we start so the next lecture about reproducibility. So with I mean the second lecture at 11, right? So it's in 15 minutes from now. Okay.
Okay, thank you very much.
Thanks.